To understand parallel resistance, you have to understand a series circuit, or the difference between a series circuit and a parallel circuit. In a series circuit, all the current flows through each of the loads or resistors. In a parallel circuit, the current flow is through each individual resistor. So that makes a big difference when you compare the circuits and how they operate in electrical systems. So we look at the series circuits in more of a pictorial or concrete fashion. You can see the little red circles are like little lamps, and they got to squeeze through all those restrictions that represent the resistors to get back to the negative terminal. Remember, what comes out of a battery comes back in. It's like a chainsaw is the motor is the battery, and the chain is the current, and it has to be powered by the battery or it goes nowhere. You can see the resistance in this just add up. As more restriction you put in the way of the flow, because each amp has to go through each restrictor, they just add up. It's a very simple relationship. So the total resistance is just an addition of all the resistance in the circuit. But a parallel circuit's different. If you can look at this pictorial, you can see that all the charges that are leaving the battery go down their individual circuits. It's like a lot of series circuits all connected together, and so each resistor hasn't got any other resistance. So as you add more of these, as you can see, there's more amps or whatever, more current coming out of the battery. If we put a fourth one in, it would be a fourth series of little dots going through. So the more of these we put in, the more amperage flow comes out of the battery, unlike a series circuit where there's less. So it increases current flow, so it becomes a totally inverse relationship. And if you inverse that relationship, then that leads to the math, and the total becomes an inverse of what it would be with a series circuit. So here you can see that process of inversing the formula, and the RT equal R1 plus R2, etc. becomes an inverse, which is when you put it over 1. So the parallel resistance formula becomes 1 over RT equal 1 over R1, and so on. If you had 10 resistors in parallel, there would be 1 over R1 to 1 over R10 eventually. So here we have a question from an exam, and it's a little more complex, but not really. You have a parallel circuit in red there, but it's got 2 resistors in each of the parallel circuits in there, and they are little mini series circuits in there, as I said, but because they're series, you just add them together, and then we have 6 ohms on one circuit and 3 ohms on the other. Now if we want to find the total resistance, again you've got to use the inverse formula, and we have 1 over RT equal 1 over R1 plus 1 over R2. That's 1 over 6 plus 1 over 3, but you have to find the lowest common denominator, and this is pretty straightforward because they're simple numbers. I mean, if you had more resistance in there, it might get a little more difficult to find the lowest common denominator, but we can find it here, and we find that 6 is the lowest common denominator, and 1/3 of course is 2/6, and 1/6 is 1/6. So they add up to 3/6. So 1 over RT equals 3 over 6. But we flip them to find the actual value, and because they were inversed, and we find that 6 over 3 becomes 2 ohms. So the answer to that problem of parallel resistance is 2 ohms. You be careful not to mix up parallel and series when you're trying to find resistance. You have to identify it and think about it as you have to in this question. So when we look at the original parallel circuit, we have 1 over 4 plus 1 over 4 plus 1 over 4 equals 1 over RT, which, as you see, we don't have the problem of a lowest common denominator, but we have 3 over 4. So we flip it again, and it equals RT equals 4 over 3, or in that circuit, it's 1.33 ohms for the parallel resistance. The comparable series circuit was 12 ohms. So you can see that there's would be a lot more current draw with a lot less ohms, because they are hooked up in parallel, not in series. So that's an overview of parallel resistance, and I thank you for your attention.